This is my conclusion about the efficient and reliable network tomography dealing with the BitTorrent broadcast. Uh, the traditional measurement and procedures for bandwidth imaging are extremely time consuming. They are proposing an innovative solution to this problem. Their method counts fragments exchanging during the BitTorrent broadcast. The properties of the underlying network play a significant role in the performance of all distributed and parallel applications which count on communications. When these properties are taken into account, communications can be enhanced. Example, in the messaging passing library, MPI, every shared operation can profit through topology understanding, particularly in the sorted networks. In this work, their goal is to provide multi-purpose automated method to reduce partitioning of the network into logical bandwidth clusters. They can aim to provide a method that's efficient to network measurement and good at finding network bottlenecks under these high load. This method will allow easy topology aware communications and highly utilized autonomous networks, which are becoming an increasingly important domain for distributed computation. The two main ways of incorporating this above the heterology of network into communication algorithms is providing such knowledge manually or automatically. Past MPI in place for grid infrastructures and other wide area networks have used each of these ways of incorporating such knowledge. Fully automatic approaches can be subdivided into internode and internode approaches. For internode approaches, network discovery typically involves some sort of communication model. There's two phases in this study, okay, to try to improve these operations. And samples of phase one, this methodologies are poor at capturing, including choke point links, while often not visible in isolating point-to-point communications. These choke points appear under conditions particularly concentrated in collective communications. They look at possible solutions these peak bandwidth measures issues in distributed computing rather than high performance computing, since diverse and tiered networks are traditionally used in this domain. First stage involves only end-to-end measurements of the network based on how these capacities are performed, whether actively or passively. They can talk of passive network imaging or active imaging. After the data is collected, the second phase of the process always involves the use of statistical methods to build a logical view of the network. While many of the metrics can be used, a number of metrics are particularly relevant in the user perspective, including the loss rate, delay, and bandwidth. Conceptually, in the first step, a concentrated communication is established between a pair of nodes until the link capacity between them is reached. Then a new pair of intensely communicating nodes is introduced, and the bandwidth of the first link is re-examined. If no changes of bandwidth is observed, then the links are probably independent. More pairs um, communicating in parallel could unveil a bottleneck or a later point. While intuitive, this approach is very expensive. The measurement procedures at polynomial complexity, even after some optimizations using heuristics and parallelism. Indeed, this complexity makes it infeasible to perform bandwidth-related networks in tomography on large-scale computer networks. The latter only attempts real experiments on small scale. Even simplified measurements and procedures require approximately 1 hour to run only 20 nodes. In our work, we introduced a novel approach to multiple source and multiple destination network topology, which differs from traditional approaches in both measurement and procedure and analysis method as follows. In the second phase, we use popular implementation of modular-based network clustering algorithm to perform analysis of measured data. We describe this process and choice of clustering algorithm as well as the operation in detail. Modular-based clustering, that is, layer visualization showing the relationship between the ground truth partitions and the groups of nodes in measured network, indicates measuring techniques is working. However, visual inspection of observed clusters is not robust and means evaluating performance. In addition, we want to tunable to automate our topology network and to deploy it on networks too large to visualize. Thus, we need algorithm clustering techniques to find clusters of nodes like those groups apparent in layout visualization. To do this, we apply a technique from modern network analysis. We use the modularity function of Newman and Garvan to identify the sets of nodes which are more densely interconnected than general level of interconnection network. Which compares for given clustering. The proportion of network edges are interclustered for each cluster against the proportion that would be interclustered in a randomized model of the same network, as described in Newman and Garvan. Quote, this quantity measures the fraction of edges in the network that connects vertices of the same type, i.e. within the communication edges, minus the expected value of the same quantity in a network in the same community diversifies the random connections between the vertices, end quote.
There aren't any real estate capsules available.
Sorry, that's my phone. Now there's another experiment that's going on called the Grid 5000. An introduction to experimental setup. This purpose of network topology method is correctly to uncover the properties of interest. In this particular work, described algorithm performs well if reconstruction is correct with regard to dynamic bandwidth properties of the network. In practice, the relationship between these dynamic properties and physical structure of the network topology is often complex. However, in order to evaluate our method, we use physical structures of the network topology, including information about how the network hardware connects compute clusters within physical sites, and information on the speed of intersite links to form around the truth data set. We perform our experiments on the Grid 5000 infrastructure in France. 9 sites were interconnected using the vector network, providing high bandwidth optical fiber. Within each site, there are different technologies, hierarchies, clusters. For this work, only Ethernet network within the sites as well as the vector network between sites are used. The prior knowledge of the network, which is independent of network topology algorithm, is very important in this work. This knowledge provides our ground truth, which we use to evaluate found in clustering. We ground truth information about multiple aspects of the system. The communication between sites of similar properties. It uses the retina infrastructure while it provides a very high intersite bandwidth. It's reasonable to assume it will not outperform the local Ethernet communication. Experiments using net PIPE confirm the assumption. For example, the maximum bandwidth achieved between nodes on the Borex and Tulsa is around 787 megabits per second compared to the 890 megabits per second achieved with the Ethernet clusters. Within the grid 5,000 site, intrusion communication is complex. Physical hardware information is typically provided online documentation available at. However, transition network anomalies can arise by observing network behavior, bandwidth bottlenecks, availability of multiple Ethernet interfaces, hardware changes, and authoritative ground truth clustering is generally best provided by the site administrator. And one more project I found, which has a YouTube video, which I can't describe in the conclusion, is the Omnet BitTorrent project. The Omnet BitTorrent project-based systems are oriented projects for research academics. It is an important simulator which provides generic architecture with object-oriented modular discrete event network simulator framework. They provide OMNET Plus model with assembled reusable components called modulars. Also, they offer MS Projects OMNet++, which ensure creation of model-based projects. They develop OMNet++ based application-oriented projects for research academics. And they also guide and support MS scholars who are interested in develop projects in the network that can simulate their application in OMNet++ from ACM papers. We analyze every network protocol performance by OMNet++. Also, we model communication networks plus connection by OMNet plus simulation. That's the end of my conclusion.